Welcome to Demystifying Math. In this lesson, we're going to be discussing trigonometric identities. We're going to start off with the reciprocal identities. We know that the sine of theta is equal to the opposite side over the hypotenuse. We have a triangle drawn where our legs are x and y, and our hypotenuse is h. The side opposite the angle theta is y, and the hypotenuse is h. For the cosecant is the reciprocal of the sine. So we're going to have h over y, or the hypotenuse divided by the opposite. The cosine is equal to the adjacent side over the hypotenuse. The side adjacent to angle theta is x, and the hypotenuse is h. The secant is the reciprocal of the cosine, so we have h over x, or hypotenuse over adjacent. The tan of the angle is equal to the opposite side divided by the adjacent side. The side opposite the angle is y, and the side adjacent to the angle is x. So we have y over x. The cotangent of the angle is equal to x over y, which is the reciprocal of the tan. So we have adjacent over opposite, or x over y. Next, we'll talk about the quotient identities. The sine divided by the cosine is going to give us y over h divided by x over h. Then simplifying the complex fraction, we get y over x, which is the same as the tan. So the tan is equal to the sine divided by the cosine. If we flip that and we do the cosine divided by the sine, we have x over h divided by y over h, which simplifies to x over y, which is the cotan. So the cotan of an angle is equal to the cosine divided by the sine. Next, we're going to talk about cofunction identities. Okay, again we have our triangle where we have x and y as our legs and h is our hypotenuse and angle theta. We also want to figure out what the other angle is. Since the three angles of the triangle must add up to 180, and one angle is already 90, the other two must share the remaining 90 degrees. So the third angle is 90 minus theta. The sine of the angle is equal to the opposite of the hypotenuse, which is y over h. The sine of 90 minus theta is going to be the opposite side of that angle, which is going to be x divided by h. The cosine is the adjacent over the hypotenuse, which is x over h. And if you're looking at the 90 minus theta angle, it's going to be y over h because y is adjacent to the 90 minus theta angle. So what you should notice is that the sine of theta is equal to the cosine of 90 minus theta, and that the cosine of theta is equal to the sine of 90 minus theta. That gives us one pair of cofunction identities. Let's also look at the tan. The tan is equal to the opposite over the adjacent, which is y over x. The tan of 90 minus theta is going to be x over y because x is opposite the 90 minus theta angle and y is adjacent to it. For the cotan, you have the adjacent over the opposite, which is x over y. And for the cotan of 90 minus theta, you're going to get y over x. So what you should notice is that the tan of theta is equal to the cotan of 90 minus theta, and that the cotan of theta is equal to the tan of 90 minus theta, which gives us another pair of cofunction identities. Next, we're going to talk about the Pythagorean identities. These arise from the Pythagorean theorem, which is a squared plus b squared equals c squared. We've drawn a triangle on the coordinate plane with a point xy at the top right-hand corner of the triangle. The hypotenuse of the triangle is 1. The lengths of the legs of the triangle are x and y. So if we tried to put this triangle into our Pythagorean theorem, a would be x, b is y, and c is 1. So we get x squared plus y squared equals 1 squared, or 1. Now what we want to do is look at the cosine and the sine of angle theta. The cosine of the angle is going to be the adjacent side over the hypotenuse, which is x over 1, or x. The sine of the angle is going to be the opposite side over the hypotenuse, which is y over 1, or y. So in our formula where we had x squared plus y squared equals 1, we're going to replace x with cosine, and sine is going to replace the y. So we end up with cosine squared plus sine squared equals 1, which is our Pythagorean identity. There are two more Pythagorean identities, and they're both derived from the one that we already found. So what we're going to do is take this equation and divide everything by cosine squared theta. And when we do and simplify, we end up with 1 plus tan squared theta equals secant squared theta, which is our second Pythagorean identity. Next, we're going to take our equation and divide everything by sine squared. And when we do that, we end up with cotan squared theta plus 1 equals cosecant squared theta. So we have two more Pythagorean identities. Next, we're going to talk about the even and odd identities. These are identities when the angle is negative instead of positive. So think about this as you have an endpoint on your terminal ray at xy. We're going to reflect that ordered pair xy over the x-axis, so it's going to become x and negative y. Remember that we just saw that x is the cosine of the angle and y is the sine of the angle. So when we do the reflection over the x-axis, we end up with the cosine of the angle and the negative of the sine of the angle. So that tells us that when we are looking at the negative angle and we want the cosine of it, it's going to be the same as the cosine of the positive angle. And if we want the sine of it, it's going to be the opposite of the sine of the angle. Then for the tan, you can simply divide the sine by the cosine. In this case, we're going to be dividing a negative by a positive, so we get a negative for the tan of theta, equal to the tan of negative theta. Now the reciprocal functions are always going to work in the same way that the original functions did. So you have the secant of the negative of the angle is the secant of the positive of the angle. For the cosecant of the negative angle, you're going to get the negative of the cosecant of the angle. And for the cotan of the negative angle, you're going to get the negative of the cotan. Next, we're going to talk about supplementary angles. These are two angles whose sum is 180. So I've drawn two of them on this circle of radius 1 here. So we have this angle theta here, and this angle is going to be 180 minus theta, because this distance from the negative part of the x-axis is theta. So instead of going all the way around to 180, we're doing theta less than that. So 180 minus theta is going to be this larger angle here. Which means what we've done here is taken this ordered pair xy and we have reflected it over the y-axis, which means that we now have the ordered pair negative xy, or the negative of the cosine of the angle and the positive of the sine of the angle. So that tells us that the cosine of 180 minus the angle is equal to the negative of the cosine of the angle itself. The sine of 180 minus the angle is going to be the same as the sine of the angle. And then to get the tan, we would divide the sine by the cosine, and we're going to get a negative this time. So the tan of 180 minus the angle is equal to the negative of the tan of the angle. Then all the reciprocals are going to work exactly the same as the original functions. Next, we're going to look at half-turn angles. And these are angles that we have added 180 degrees to the angle measure. So if you think about it this way, we've gotten theta here, and then we're going to go another 180 to get over here, which means that we've done a rotation symmetry with that ordered pair. So if you have xy over here, it's going to become negative x, negative y in quadrant 3. And that means that we went from cosine sine to negative cosine negative sine. So that tells us that the cosine of 180 plus an angle is equal to the opposite of the cosine of the angle. The same holds true for the sine. But then when we divide the sine by the cosine to get the tangent, we're going to get a positive. So the tan of 180 plus the angle is equal to the tan of the angle. And all your reciprocal functions work in the same way. Okay, so now we've learned all these identities. Let's put them to work. We're given that the cosine of an angle is -1/4 and that the sine of the angle is positive. So we want to be able to figure out what is that sine of the angle. So in order to solve this, what we're going to do is use our Pythagorean identity, which is cosine squared plus sine squared equals 1. We're going to replace the cosine with -1/4. And then we're going to square it and isolate the sine. So we get sine squared equals 15/16 and then take the square root. Now normally we put plus or minus when we take the square root, but since we already know that the sine is greater than 0, we're going to take the positive of the square root. So we have the sine of theta equals the square root of 15/4. All our identities allow us to find the different trigonometric ratios for the angles without having to actually find the angle itself. Next, we're going to work on quotient identities. Alright, so we already know that the cosine of the angle is -1/4 and the sine of the angle is the square root of 15/4. We can find the tan by dividing the sine by the cosine and simplifying. So we get negative square roots of 15. We can also find the cotan by dividing the cosine by the sine, or you could take the reciprocal of the tan, and we get negative square root of 15/15 after rationalizing. Next, we're going to talk about even odd identities. We wanted to find the sine of the negative of the angle theta, which we decided was equal to the negative of the sine of theta. So we're just going to take the opposite of what we had for the sine of theta. So we have negative square root of 15/4. The cosine of the negative of the angle is equal to the cosine itself, so we have -1/4. The tan of the negative of the angle is equal to the opposite of the tan of the angle, so that's going to give us a positive square root of 15, since the tan was already negative. The cotan of the negative of the angle is equal to the negative of the cotan of the angle. Remember, the reciprocal functions do the same thing as the original functions. So we get square roots of 15/15. Okay, so we found these 4 items, and we're going to use those to help us find more things. So let's look at our cofunction identities. The sine of 90 minus theta is equal to the cosine of theta, so that's going to give us -1/4. The cosine of 90 minus theta is the sine of theta, so we're going to use the square root of 15/4. The tan of 90 minus theta is equal to the cotan of theta, so we have the negative square root of 15/15. Next, we're going to look at some supplementary angles. The sine of 180 minus the angle is equal to the sine of the angle, so we have the square root of 15/4. The cosine of 180 minus the angle is equal to the negative of the cosine of the angle, which is 1/4. For our half-turn angles, we have the sine of 180 plus the angle is equal to the negative of the sine of the angle, so we're going to have negative square root of 15/4. And the cosine of 180 plus the angle is equal to the negative of the cosine of the angle, which is going to give us positive 1/4. Of course, you could do this with all the reciprocal functions, the tans and the cotans as well. These are just a few of the examples of things that you can find out just by knowing 2 pieces of information. The cosine of the angle was -1/4 and the sine was positive. So keep working on some of these, and thank you for tuning in to Demystifying Math.